Good day. Let me introduce the AI for 2020 Predictive Maintenance Dataset. It is a comprehensive synthetic dataset designed to emulate predictive maintenance data commonly found in industrial applications. It contains 10,000 instances with 6 features, and its key attributes include being multivariate, time series, and real valued. The dataset is structured for various machine learning tasks, including classification, regression, and causal discovery, making it highly versatile for analyzing maintenance needs and operational efficiency. So let's go to explain this dataset. This dataset was selected because it aligns well with the growing interest in predictive maintenance across industries. Predictive maintenance leverages machine learning to forecast potential failures in industrial equipment, minimizing downtime and optimizing resource allocation. The dataset's synthetic nature makes it both accessible and suitable for academic or industrial experimentation without concerns about sensitive proprietary data. Furthermore, its structure and size provide an excellent platform for testing and improving machine learning algorithms. Importance of the AI for 2020 predictive maintenance dataset lies in its ability to simulate real-world maintenance challenges. Predictive maintenance is crucial for industries aiming to reduce operational costs, enhance equipment reliability, and improve safety standards. This dataset provides a benchmark for developing and evaluating predictive models, which can aid in early fault detection and decision making. By enabling researchers and practitioners to create and validate models in a controlled setting, the dataset contributes significantly to advancing the field of industrial automation and smart manufacturing. So, from the data pre-processing, the question is, what pre-process did you make? In this dataset, I use data cleaning, where in this process, it involves removing or correcting inaccurate, incomplete, or should I say, irrelevant. Then I use the handling missing data, where in this technique, it is an essential in data processing to ensure accurate analysis. In the selected attribute that represents the ID of each client, there are 0% missing data, 10,000 distinct, nominal type of attribute used, and 100% uniqueness of the data. So let's go to the third part, the data mining. For the clustering, the classes to clusters evaluation is a technique used in unsupervised learning to compare the performance of a clustering algorithm against predefined class labels in the dataset. This evaluation measures how well the clusters produced by the algorithm align with the actual classes present in the data. So let's go for the classification. A decision tree is a predictive model that splits data into branches based on feature values, leading to a decision outcome. And the tree consists of nodes, edges, and leaves. Where the nodes, it represents features or the attributes, the edges denoting decisions or splits, and for the leaves, it is the final outcomes or the classes. So from the Classifier performance. It includes the number of rules where only one rule was generated. It's likely due to the low correlation between attributes and the target class as indicated by the poor performance metrics. And the best subset selection, it evaluated 58 subsets of attributes. However, the merit of the best subset found is quite low, suggesting weak predictive power. Overview of classification sheet. The decision table classifier, it summarizes the dataset using a compact set of rules galing sa data. It selects features and creates a decision table that predicts the target variable by examining combinations of selected attributes. For the cross-validation results, it includes the correlation coefficient, where negative 0.0097 indicated almost no linear relationship between the predicted and actual values, and the mean absolute error, where 0.0038, showing small errors in individual predictions, but it's relative to the target value range. And for the root mean squared error, 0.0436, is slightly higher than the mean absolute error, combining small errors and occasional large errors. For the relative errors, under this is the relative absolute error, meaning the model performs as poorly as random guessing, and the root relative squared error, confirming the model's lack of predictive accuracy. Clusters. In clustering each group, this group represented by different colors in the visualization is a cluster that groups similar data points based on their attributes. From the graph, the data points, the colored markers are distributed diagonally and differentiated by product ID or some categorical attribute. The colors represent different clusters identified by the EM algorithm. The diagonal alignment, since both axes are based on product ID, the diagonal pattern is expected as the x and y axes are the same. Interpretation of the graph, it includes the dense areas, color clusters, and diagonal distribution. Where the dense areas, it shows the clusters overlapped, or where the data points are concentrated. These areas are of interest for further analysis. And for the color clusters, the distinct colors indicate how well the clustering algorithm separated the data. And the diagonal distribution, it is a result of the same attribute being plotted on both axes, indicating a near linear relationship. Each cluster corresponds to a group of data points with similar values for the dataset attributes. Example of this are the temperature, torque, machine failure types. So from the visualization, the cluster colors. Each color represents one of the identified clusters. The cluster with the most points is dominant. It overlaps in colors may indicate its data points that do not clearly belong to a single cluster. And for the last is the class correlation. The Weka tries to align the clusters with predefined classes. Example of this are the machine failure types. So let's start with the summary. The analysis of the AI41 2020 predictive maintenance dataset using clustering and classification methods revealed several key insights. The clustering results from the EM algorithm show that the data points were grouped into clusters based on operational parameters such as torque, temperature, rotational speed, and tool wear. While the clustering algorithm identified the meaningful groupings in overlaps as a cluster assignments, it suggests the complexities in the data not readily attributed to insufficiently distinct features. Classification using the decision table model showed poor performance with a high relative absolute error of 100.08% and a low correlation coefficient of negative 0.097. This indicates that the current attributes may not adequately explain machine failures or are weakly correlated with the target variables. Visualization of the clusters highlighted areas of dense overlap, further emphasizing the need for more discriminative features to improve machine learning outcomes. And for the recommendation from the AI 41 2020 predictive maintenance dataset, to improve this dataset's utility and the accuracy of predictive models, several recommendations are proposed. Una is the additional feature engineering should be prioritized by including factors among environmental conditions, the maintenance history, where it could provide stronger correlations with machine failures. The redundant attributes or yung mga nauulit, like product ID, should be also be eliminated to enhance the model performance. And pangalawa, it addressing the class imbalance is crucial. So it is important as underrepresented failure types could skew results. This can be mitigated by generating synthetic data using techniques like SMOT, or it should pronounce smooth, or collecting additional real-world data to ensure balanced representation. And lastly, refining data collection and pre-processing processes is essential. Ensuring that this all data is consistent, free of noise, and appropriately scaled will improve the reliability of machine learning models. So from these recommendations, it enhanced the dataset's effectiveness in supporting this predictive maintenance and reducing and okay, I'll correct it, and reducing machine failures. Thank you.